There is no physical clock that can be placed 1 second before God. That sentence sounds theological, but the first problem is not theology. It is physics. The word before is not empty. In physics, before means that two events can be ordered along a time coordinate. One event has a smaller value of time. The other has a larger value. A clock could in principle tick between them. But if time itself is part of what the universe is, then asking what happened before the universe is not like asking what happened before sunrise. It is like asking for a temperature north of the North Pole. The grammar survives. The physical meaning collapses. The question, what existed before God, has the same hidden trap. It smuggles in a clock. It assumes there is a background time already running, a silent stage on which even God must appear at some earlier or later moment, but that is not the way modern physics learned to treat time. Newton could speak as if time flowed uniformly everywhere, independent of stars, atoms, observers, and motion. Einstein broke that picture. In special relativity, time is not a universal river. Two observers moving relative to one another can disagree about which distant events happened at the same time. In general relativity, the situation becomes deeper. Time is woven into the geometry of space-time, and that geometry is affected by energy, momentum, pressure, radiation, and matter. Time is not merely where events happen. Time is one of the things being shaped. The simplest way to see the difficulty is not to start with God. Start with a clock. A clock is not a magical object that measures an invisible flow. A clock is a physical system that changes regularly. A pendulum swings. A cesium atom oscillates. A quartz crystal vibrates. A planet rotates. To say that time passes means that physical systems can pass through ordered states, but those systems require a universe. They require fields, particles, motion, energy differences, interactions. Remove all physical structure, and the word clock has no operation left to perform. Not a broken clock, no clock. This is the first mechanism beneath the question. Before is not a mood. It is a relation between physical events and relativity. An event is a point in space-time, something with coordinates, one time coordinate, and three space coordinates. The interval between events is not measured by time alone because different observers split space-time differently into space and time. The invariant interval spoken in flat space-time is s squared equals minus c squared t squared plus x squared plus y squared plus z squared depending on sign convention. The speed of light c is exactly 299,792,458 meters per second. That number is not just fast. It is the conversion factor between space and time. It tells you how many meters of space correspond to 1 second of time in the geometry of the universe. Once you take that seriously, the ordinary phrase before creation changes shape. If the universe includes space-time, then creation is not an event inside a pre-existing time. It is, at least in the language of physics, the boundary or origin of the space-time description itself. That does not prove God. It does not disprove God. It does something colder and more exact. It removes a false picture. The universe is not a room into which matter was poured. The room is part of the universe. This is where the surface explanation conceals something stranger. General relativity gives spacetime its equation. In spoken form, the Einstein field equation says g mu nu plus lambda, g mu nu equals 8 pi g over c to the fourth times t mu nu. The left side describes geometry, curvature, the metric, the cosmological constant. The right side describes energy and momentum, matter, radiation, pressure, fields. G, Newton's gravitational constant, is approximately 6.67430 times 10 to the minus 11 cubic meters per kilogram per second squared. That c is the exact speed of light. The equation does not say gravity is a force pulling objects through empty space. It says energy and momentum are related to the curvature of space-time itself. Now apply that equation to the entire universe, but strip away everything unnecessary. Do it the way a physicist would. Assume that on the largest scales, the universe is roughly homogeneous and isotropic. Homogeneous means no special place. Isotropic means no special direction. The mathematics then collapses into a simpler form called the Feynman equation. Spoken plainly, it says h squared equals 8 pi g over 3 times rho minus kc squared over a squared plus lambda c squared over 3. H is the expansion rate, rho is the energy density. A is the scale factor, the number that tells you how much cosmic space has stretched. K is the curvature term. Lambda is the cosmological constant. That equation is not decoration, it is the insight. If the universe is expanding today, then going backward in the equation makes the scale factor smaller. Smaller scale factor means galaxies were closer, radiation was hotter, matter was denser. Push the classical equation far enough backward, and the density rises without limit. The temperature rises without limit. The curvature rises without limit. The mathematics does not give you an ordinary explosion. It gives you a failure point, a singularity. But a singularity is not a thing. It is not a tiny marble containing all matter. It is the place where the theory stops, giving a physical answer. When the equation returns infinity, the correct response is not to worship the infinity. The correct response is to ask which assumption broke. General relativity is a classical theory. Quantum mechanics governs matter and radiation at very small scales. Near the beginning, the universe was small, hot, dense, and violently quantum. Using classical space-time all the way to zero is like using the rules of ocean waves to describe a single water molecule. It worked until it had no right to work. The scale where this failure becomes unavoidable is the Planck time. Spoken as an equation, the Planck time is the square root of h bar times g divided by c to the fifth. H bar is Planck's constant divided by 2 pi, about 1.054571817 times 10 to the minus 34 joule seconds. G is the gravitational constant. C is the speed of light. Put them together, and the Planck time is about 5.391247 times 10 to the minus 44 seconds. That is not merely a small fraction of a second. It is the timescale at which our ordinary separation between quantum theory and space-time geometry becomes untrustworthy. Before that, the honest statement is not that there was nothing. The honest statement is that our tested equations no longer tell us what the word before means. This is the mistake people make when they say physics has shown that the universe came from nothing. Physics has not shown that. Physics has shown that the observable universe was once in a hot, dense state, and that our classical description, when extrapolated backward, reaches a boundary where it breaks. Nothing is a philosophical word, unless you define it operationally. A quantum vacuum is not nothing. It has fields, it has fluctuations, it has structure, it obeys equations. Calling that nothing is a trick of language, not a result of experiment. The evidence for the hot early universe is not weak. In 1927, Georges Lemaitre, a Belgian physicist and Catholic priest, used Einstein's equations to argue for an expanding universe. In 1929, Edwin Hubble measured a relation between the distances of galaxies and their recessional velocities. The farther the galaxy, the faster it appeared to recede. Later, the relation would become known as the Hubble law, and more precisely now, the Hubble-Lemaitre law. The religious identity of Lemaitre is not the argument. The equation is the argument. The observation is the argument. A priest helped invent Big Bang cosmology, but the theory survived because telescopes, spectra, and equations forced the issue. Then came the microwave sky. In 1965, Arno Penzias and Robert Wilson at Bell Labs found a persistent microwave noise they could not remove. It did not come from New York. It did not come from the instrument. It did not come from pigeons in the antenna, although they cleaned those out too. It came from every direction. That radiation is now called the cosmic microwave background. Its average temperature is about 2.725 Kelvin, only 2.725 degrees above absolute zero. It is relic light from the early universe, stretched by expansion into microwaves. Modern observations place the surface of last scattering roughly 370,000 to 380,000 years after the beginning of the hot Big Bang phase, when electrons and protons combined into neutral atoms and photons could travel freely. The universe became transparent. This matters because it changes the conversation from mythology to measurement. If someone asks what existed before God, science cannot put God into a detector. But science can ask whether the physical story being assumed has any measurable content. Did the universe have a hot, dense past? Yes. Is expansion observed? Yes. Is relic radiation observed? Yes. Do the equations of general relativity, applied to a homogeneous universe, point backward toward a state where classical space-time fails? Yes. Does that failure equal God? No. Does it eliminate God? No. It is a boundary of physics, not a trophy for either side. Feynman's way of thinking is useful here, because he had almost no patience for labels pretending to be explanations. If you call the origin of the universe God, you have not yet explained a mechanism. You have named the place where your explanation stops. That may have religious meaning. It may have existential meaning. It may have moral meaning. But as physics, the next question is always the same. What changes if the statement is true? What number would be different? What observation would fail? What experiment could, even in principle, distinguish that answer from another one? In 1956, in a talk at Caltech on science and religion, Feynman said that science cannot disprove the existence of God. He also insisted that science lives by uncertainty. That combination is important. It means the scientific answer is not the cheap answer. It is not, there is no God because I cannot calculate God. It is not, there must be God because I cannot calculate the beginning. Both are lazy in opposite directions. The harder answer is that science grades belief by contact with reality. Where there is measurement, it measures. Where there is equation, it calculates. Where there is no test, it refuses to pretend. The phrase before God may belong to theology, but the phrase before the Big Bang belongs to physics only if we define Big Bang carefully. The Big Bang is not necessarily the absolute beginning of all reality. In modern cosmology, it usually means the early hot dense phase from which the observable universe expanded. That phase is strongly supported. The absolute beginning is not. There are models in which time has a boundary. There are models in which a quantum transition replaces the singularity. There are bouncing cosmologies in which a contracting phase preceded expansion. There are inflationary models in which our observable universe is one region of a larger structure. There is the Hartley-Hawking no-boundary proposal, where asking for an earlier time becomes like asking for a point south of the South Pole in imaginary time. There are tunneling proposals. There are loop quantum cosmology bounces. There are eternal inflation scenarios. They are not equally established. Some are mathematical possibilities. Some make partial predictions. None has the same status as the measured microwave background. Evidence calibration matters. The cosmic microwave background is not a philosophical preference. It is a measured radiation field. The expansion of the universe is not a mood. It is inferred from redshifts, distances, and a century of astronomical data. Big Bang nucleosynthesis, the formation of light elements in the early universe, is a quantitative success. Inflation is a powerful framework that explains why the observable universe is so smooth, flat, and causally puzzling, but the exact mechanism of inflation is not known. Quantum gravity before the Planck time is not established. A multiverse is not established. A final origin is not established. The sentence "we do not know" is not a weakness in physics. It is one of its instruments. Now return to God. Classical theology often describes God not as the first object in time, but as the ground of time itself. If that is what is meant, then the question what existed before God is internally confused. It treats an atemporal cause as if it were a temporal object. Physics cannot verify the theological claim, but it can expose the temporal assumption. A God outside time does not arrive late. A God inside time is no longer the ultimate explanation of time. In either case, the word before must be handled with care. This is not wordplay. It is the same discipline that relativity forced onto simultaneity. Before Einstein, people thought simultaneity was obvious. Two events either happen at the same time, or they do not. Einstein asked how you would measure it. You need clocks. You need light signals. You need a convention for synchronization. Once you do the operation honestly, simultaneity becomes frame-dependent. The old intuition was not deep. It was unexamined. The same thing happens here. Before feels obvious until you ask what physical operation gives it meaning at the origin of time. The deepest version of the problem is not whether something existed before God. It is whether existence itself requires time. In ordinary life, to exist means to persist through moments. A chair exists because it is here now, was here a second ago, and may be here a second later. But physics already knows forms of description, where time is not fundamental in that ordinary sense. In the block universe view suggested by relativity, space-time is a four-dimensional structure. Events do not come into existence, one by one in the equations. They are located in space-time. Your experience of passage is real as experience. But the equations do not require a universal cosmic now sweeping across reality. Past, present, and future are not arranged for all observers in the same absolute slicing. Quantum theory complicates this further. Feynman's path integral formulation says that to calculate the probability amplitude for a particle to go from one event to another, you sum over all possible paths, not the path you can picture, not the sensible path. All paths weighted by a phase determined by the action. The spoken form is the amplitude is the sum over paths of e to the I times s over h bar. S is the action measured in joule seconds. H bar is the quantum of action divided by 2 pi. The classical path emerges when neighboring paths reinforce one another, and wildly different phases cancel. The ordinary world is what survives the sum. That does not answer the origin of the universe, but it teaches the right humility. The universe is not obligated to respect the categories that human grammar evolved to use. A particle does not need one visible path. Space-time does not need one universal present. The origin does not need a before, if before is part of the structure that begins. The mathematics does not care what we find intuitive. This is why the question is powerful, even though it is badly formed. It presses on the seam between three languages: physics, metaphysics, and theology. Physics asks what can be measured, modeled, and predicted. Metaphysics asks what existence, cause, and necessity mean. Theology asks about God, purpose, worship, and ultimate dependence. Trouble begins when one language steals words from another without paying the price. Cause in a laboratory is not always cause in metaphysics. Nothing in quantum field theory is not. Nothing in philosophy, beginning in cosmology, is not automatically creation. In theology, before, in ordinary speech, is not before at the boundary of time. Feynman would not have solved this by pretending the mystery is gone. He would have cut away the false certainty. If by God you mean a physical being located at an earlier time, then physics can ask what fields, energies, interactions, and evidence correspond to that being. If by God you mean the reason there is a lawful universe at all, then physics may describe the laws, but not step outside all law and explain why there is law. If by before you mean a measurable earlier state of the universe, then cosmology can investigate models before the hot dense phase, but it must admit where observation ends. If by before you mean something outside time, then the word has changed meaning. The honest result is not satisfying in the ordinary way. There is no simple picture. There is no cosmic clock ticking in darkness, then God, then universe. There is no experimentally confirmed sentence that says absolute nothing turned into something. There is no equation that turns God into a variable. There is a measured expanding universe, a relic microwave glow at 2.725 Kelvin, a hot dense early phase, a classical theory that breaks near 5.39 1047 times 10 to the minus 44 seconds, and an unresolved demand for quantum gravity. Beyond that, confidence must drop. But dropping confidence is not defeat. It is the beginning of accuracy. A child asks what came before everything and expects another thing. A physicist asks whether before still has an operation. A theologian asks whether the source of time can be inside time. A philosopher asks whether existence depends on temporal order. These are not the same question. Treating them as one creates an answer that sounds grand and means almost nothing. So what existed before God? If God means a thing in time, then the question pushes that God backward and asks for a prior cause, and the chain continues. If God means the source of time, then before God is not false. It is undefined. If the question is really what existed before the universe, the answer from physics is narrower and stronger. The observable universe came from a hot, dense, early state, but before the Planck boundary, our tested theories no longer give a settled physical description. Not approximately, not secretly, not yet. The strange thing is that this does not make the universe smaller, it makes the question cleaner. The mystery is not a fog placed over ignorance. It is a border drawn by what the equations can honestly say. On one side are clocks, photons, atoms, galaxies, curvature, expansion, and radiation. On the other side is not automatically God, and not automatically nothing. It is the place where the word before waits for a theory that can earn it.